Hi there everybody, welcome to another MCAT ACE lecture, and in today's lecture we're going to be working with general units and conversions. So this is one of the first things that students will learn in general chemistry when they come across one of their first chemistry courses. So before you start getting into the atoms and all of the other material in terms of actual chemistry and electrons and things like that, most people will go through a units and conversions chapter at the beginning of their course. And this is very important because it's going to carry through to any other chemistry field or process that you would be doing some sort of math in. You're usually going to find conversions, and you will certainly come across units where you need to understand the difference between Celsius and Kelvin, or grams and moles, and things of that nature. So this is a very basic unit, but it's a very important unit that you are comfortable with. Especially if you are taking the MCAT, you cannot be wasting excessive time trying to figure out conversions. You need a strong methodology as far as how you're going to set them up, execute them, and then move on to the next question in your limited time window. So you want to make sure that you've got this stuff down before you go on and you start mastering the content. So what are we going to talk about here today? Well, the first major topic that we need to bring up is significant figures. There tends to be a lot of confusion around significant figures even once students get out of general chemistry. So it's very often I'll find students that are writing organic chemistry lab reports, they're doing their limiting reactants or things like that, and significant figures have kind of gone out the window and people aren't focused on them as much anymore because you're on to bigger and better things, so to speak, when you're learning all these new reactions. However, it is very important that you understand and you observe significant figures when you are reporting any data or any scientific work that you are, whether it's publishing, reporting, and handing to somebody else you're working with. You need to keep track of that kind of stuff. And we'll talk about why, the meaning and why they're important. We'll certainly go over the rules as to what makes something a significant figure or not, and we'll have a brief discussion on accuracy versus precision, which is one of those common topics that always comes up in first semester chemistry. Then we'll take a brief look at scientific notation, which is the idea of taking either very large or very small numbers and shrinking them down into a more manageable written form, and then we use some sort of an exponential multiplier. So you usually see something times 10 to, and then it's a given power. So for example, 2 times 10 to the 7th. And that would represent taking that 2 value and then putting a bunch of zeros after it until you hit the millions value, the 10 millions there. So we'll take a look at that, going in both into scientific notation and out of it. What if I want to get out of scientific notation and actually write that very large or very small number? We will discuss common SI units, which are the standard international units, particularly the metric system. It's what everybody agrees upon as they're working with this in the scientific community. So especially for those that are viewing in the United States, we typically have the imperial system, and we're using things like gallons instead of liters. We use pounds instead of kilograms, and so you'll come across differences in that. And that's part of what we're going to head into with dimensional analysis afterwards, is how can I convert. Let's say somebody says, I've ordered 7.55 pounds of this compound. What would that be in grams? You need to be able to convert that and go back and forth, right? So that's the idea of dimensional analysis. You're going from one dimension or unit to another when you're converting back and forth. We'll take a look at some problems like that. And then with the SI units, we also want to talk about prefix values, right? So what is kilo or milli or micro, or all these terms that come up, what do they mean? Because they're sort of modifiers that go on to base units, right? So for example, a base unit would be grams, and then you could have a kilogram, or you could have a microgram or a nanogram. We're still having the same base unit in each of those cases, the gram. However, that prefix is a modifier to tell us how much of that particular base unit, whether it's larger or smaller than the relative base unit that we would normally consider our standard unit. So at the end, we will definitely have our practice and summary as usual, but other than that, let's go ahead and get this underway and start talking about significant figures.